Hello, my name is Ava Hudson, and I will be presenting my Capstone project today as part of the Lehigh Energy Systems Engineering Project, our master's program. And my project sponsor is Fellowship Energy. So thank you for tuning in. So the title of my presentation is Installing Small Modular Reactors at Decommissioned Coal-Fired Power Plants. So this just shows a quick overview of what I will be covering today, starting with the introduction and project scope, and then eventually the methodology and all that other good stuff. So in light of climate change, the U.S. is working to decarbonize our energy sector by decreasing our reliance on fossil fuels like coal and natural gas that contribute heavily to greenhouse gas emissions. The number of coal-fired power plants in the U.S. continues to dwindle, as shown by the image on the slide that depicts the amount of coal generator retirements that were planned for 2022 alone. With growing pressure to proclaim an end to coal, the U.S. recently announced at COP28 that we are planning to eventually shut down every coal plant not equipped with carbon capture, sequestration, and additional pollution technologies that are very expensive. So as we decommission more and more of our aging coal fleet, we're also adding a significant amount of renewable energy to the grid, especially solar and wind power, which have new attractive financial incentives available, like under the Inflation Reduction Act. So as these trends are happening, challenges are introduced to the also aging grid because solar and wind are intermittent. So their power output varies with the weather conditions, and energy supply does not always align with energy demand, as shown in the graph on the right. So to maintain a reliable supply of energy on the grid, energy storage and peaker plants are required. Energy storage technologies, though, are expensive to install and can tap into a limited number of value streams as standalone assets. So this leads to coal and natural gas being used primarily for peaking plants. And these coal and natural gas peaker plants are being called on to act as baseload power more often too. So the really bad thing about this is that these plants produce more greenhouse gas emissions than even just traditional coal and natural gas plants. And they produce an insane amount more compared to, nuclear, hydropower, and geothermal plants. So the question remains, how do we maintain a reliable grid and, our energy security in a net zero carbon future? One answer is in nuclear power. So nuclear power is designed for high capacity factor output, but conventional nuclear reactors are expensive and time consuming to build, so they're less competitive than fossil fuels. However, new small modular reactors, or SMRs, could be the right answer. These are advanced nuclear reactors, primarily pressurized water reactors, ranging from about 20 to 300 megawatts per unit, So these SMRs provide carbon-free, reliable, and flexible electricity that work well when coupled with intermittent renewables. Each unit is a fraction of the size of conventional large-scale nuclear reactors, and because they're modular, the components can be factory assembled and easily transported as a unit for installation, which drastically reduces build times and upfront costs. Also, multiple units can be installed at one site to increase the total output. So NuScale, which you can see that one of their reactors is pictured on the right, they have a 77 megawatt SMR that can be configured in a 4, 6, and even 12 module plant that has a net capacity of 884 megawatts. So despite the many advantages of SMRs, there are a variety of challenges that remain in the way of proving their market viability to make it more cost competitive with other generation sources. One of the biggest hurdles with SMR development and nuclear development in general is determining suitable locations to increase the project's financial viability, because purchasing, new greenfield sites for nuclear generation can be extremely difficult to do and very expensive. So with the increasing number of retired coal plants in the U.S., one solution that's being explored to increase the market viability of SMRs is to install them at decommissioned coal-fired power plants. And you can see a rendering of this on the bottom. So the DOE, EPRI, and Oak Ridge National Lab have been interested in this idea, given the potential benefits that come from choosing a coal plant instead of a greenfield site. So there's, avoided land acquisition costs. You can reuse similar balance of plant systems, and it can also provide increased regional economic activity. which, this proving the market viability is becoming a really important topic, especially in light of the recent cancellation with one of NuScale's 6-module SMR projects. It was due to a lack of customer willingness to finance it. So that brings me into the purpose of this project, which is to ultimately determine the feasibility of installing SMRs at a decommissioned coal-fired power plant in Pennsylvania specifically. We have a large, coal fleet here historically, to provide carbon-free baseload electricity. The scope of work that was done for the semester was looking to identify the most suitable retired coal plant in Pennsylvania for SMR deployment based on relevant nuclear siting criteria. And then to identify key coal plant criteria or characteristics that have the highest potential to improve SMR market viability through targeted development. So getting into the how to do this, and you can see just another rendering of this idea on the bottom. The first step was to select appropriate siting criteria for nuclear reactors, determine a scoring matrix for each one to reflect, how much it increases a site suitability. Then each plant identified in Pennsylvania would be evaluated against this criteria to then build a composite score to categorize them based on their level of viability for SMR installation. So I know there's a lot of information on this slide. I will go through each one pretty briefly though, to try to keep this presentation as close to 15 minutes. So there's many potential site selection criteria for nuclear power plants that are related to public health, safety, economics, environment, other engineering factors, but the selected criteria in this report are based on published works from the DOE, EPRI, Oak Ridge National Lab, that are considered to have the most impact on the viability of a site for SMR installation. And they're primarily based on general nuclear reactor guidelines as they apply to both large and small reactors. So to ultimately determine the viability of a decommissioned coal plant, we needed a quantitative metric. So many of the criteria are quantitative in nature, which made it easy to assign a scale to them. But we also have some that are truly qualitative parameters, pretty much black and white, such as protected lands and non-attainment zone, that are two binary criteria. So it either is or it isn't. It's either in protected lands or it's not. It's either in a non-attainment zone or it's not. Other criteria, however, relied on a range of values or inputs. So they had a 5-point scale assigned to them, ranging from 0 to 4. So in this scale, a site that receives a 0 would represent a site that's basically least suitable for SMR installation, and then a score of a 4 is the most suitable. So in addition to determining the scoring matrix for each parameter, we also had to determine if any of these criteria were sort of fatal flaw or absolutely necessary criteria, and identify which ones would, if earning a 0 in them, completely eliminate a site from being developed. So those two were identified as population density, and then protected lands. Those ones, if a site earns a 0 in either of those, there's pretty much a 0% chance that it would be developed. So those are two of our requirement criteria. And this will make sense a little bit more when I show you the equation to use that we used when determining the final scores. So I will go through each one just in the order that plants would be evaluated, starting with the 2 fatal flaw criterias. So basically any site that was located within protected lands and included national parks, historic areas, wild refuges, they would receive a 0 and would not be suitable. They would not be built essentially on protected lands. So that one's pretty straightforward. Going on to the second fatal flaw criterion, population density is a really important safety parameter. EPRI's analysis excluded sites with a population density greater than 500 people per square mile within a 10-mile radius of the site, which is based on regulatory guidelines. There had been talk about possibly lowering that buffer zone down to a 4-mile buffer zone, but to remain on the conservative side, we did the population density within 10 miles. So again, anything over 500, that's not going to be developable really just due to the high population. So that's going to get a 0 and would be excluded basically from further consideration. Looking at the physical site characteristics, NuScale's 12 module SMR site, which is one of the biggest ones, only requires about 34 acres. So we had 30 acres as our cutoff value. 50 was used in other reports as sort of a happy medium, and then anything over 90 would earn a perfect score. When looking at site slope, this is partly a technical factor, like engineering factor, but it also has economic considerations because the higher the slope, it doesn't, preclude a site from being developed for SMRs, but it would incur significant additional, construction sites to prepare the site and actually level it. So that would earn a score of 0, but it's still technically possible for SMRs to be put there. Looking at environmental hazard criteria, we have earthquake, landslide, and flooding, which are, general hazards that are pretty much considered for all power generators, not just nuclear, but, are especially particular to pay attention to for nuclear, given the chance of a possible meltdown. So earthquake, that's based on safe shutdown, earthquake speed, essentially it's peak ground acceleration. And then landslide and flooding is based off of FEMA, Federal Emergency Management Agency, their designated risk levels. Then looking at the amount of stream flow that's available at each site, essentially SMRs require a certain amount of water for, operation. And so previous studies had kind of noted 65,000 was a happy medium, 130 was sort of the gold standard. A number of studies also estimated that nuclear plant water demands could be reduced through the use of dry cooling, taking the required stream flow value all the way down to 10,000 gallons per minute. So that's our low end value. Looking at transmission infrastructure, this is kind of similar to site slope. Anything over 25 miles, it'd be possible for an SMR to be put in there, but it's not very likely that someone is going to want to have to then pay to have 25 miles worth of transmission infrastructure installed. So anything under 5 miles, the cost impact it would have is not very significant. So that would be a, good site to still pursue. The number of nearby hazardous facilities, and I'll list the specific kinds of facilities included later on. That's just something important to note in terms of how difficult it would be to install a nuclear power plant in places. So again, I'll kind of explain that more as I go through each one in the results. Environmental justice, looking at historically, environmentally hazardous facilities like power generating stations have been built in economically impoverished communities, primarily made up of minority populations, which has resulted in environmental devastation and detrimental health impacts that are disproportionately affecting these vulnerable communities. So to avoid exacerbating this existing issue, a retired coal plant that's located within an environmental justice area would be less favorable for SMRs. From an ethical perspective, this criterion could be considered as a requirement for SMR siting. However, technical guidelines do not exclude environmental justice areas. So as a siting criterion, low score was not considered a fatal flaw in this report, rather just a measure of suitability. And then the last criterion that we looked at or included was whether or not the sites were located within EPA non-attainment zones, which is essentially any zone that it does not meet the national ambient air quality standards for ozone or particulate matter, which are two of the EPA's criteria pollutants that coal plants emit. So citing a greener source like nuclear in those areas could be a more preferred option. So in building the composite site scores, the scoring formula was not just a simple sum of values. So instead we have protected lands and population density are two fatal flaw criteria. They're actually multipliers, so they would get multiplied against the sum of the remaining criteria. And then those are all normalized against a perfect score of 148, just to have a more uniform interpretation of the data. And then based on the normalized scores that each site would receive, they would fall into one of the 4 site status categories. And just ultimately the goal is to make a quantitative and repeatable approach to all of this. So bear with me as I go through all of the results and discussion. So 13 decommissioned coal plants were identified in Pennsylvania. Of those 13, 8 of them had already been redeveloped, leaving 5 potential ones to be evaluated. They all had generating capacities of what we were looking for between 50 megawatts and 600 megawatts, which was basically determined as like an acceptable range given the desired output that SMRs can provide. And then here it just shows them on the map. So we have 4 in the western part of Pennsylvania and 1 over in the eastern part. And just kind of important to note, Mitchell and Alrama, the ones that are right next to each other in the lower left, they are in fact located in the same census tract, which will come into play again later. So going through each criterion and the results that we had, I'm going to do this fairly quickly, just touching on the ones that had interesting results. So protected lands, they all did fine on this. None of them were in protected lands, which working with decommissioned plants, it's unlikely that any of them would be located on protected lands. You know, since the coal plant has been decommissioned, it is possible that a portion of it could be designated as protected lands, like parklands, for example, but that's not the case here. So they're all still potentially viable. Looking at, population density. So Oak Ridge National Lab's land scan was used, which was a high resolution population distribution database. And so Crombie fails to meet the population density requirement. It has over 500 people per square mile. So that earned a 0 in this. And again, we have to remember that this is a multiplier. So we pretty much know off the bat right now, Crombie's going to get a score of 0 because of this, because having the high population there just really makes it a non-desirable place. So just to touch on this a little bit more. So here is an actual picture of the land scan map, and then you can see the locations of the different coal plants on it. So the range of population density values doesn't support an observable relationship between coal plant locations and areas of low population, as most of the coal plants are located near Pittsburgh and Philly, or most of the coal plants in this report at least. So remember that this, because it is a multiplier, the drop off in scores between Crombie and Armstrong will have a major impact on increasing Armstrong's overall site suitability. And unlike nuclear plants, coal plants don't have as stringent regulations when it comes to siting them near populated areas. So this is an important criterion that should be considered when looking at coal plants for SMR siting. A bit of additional analysis was done that looked into the expected annual growth rate of the census tract at each plant is in for the next 5 years. It was thought, identifying positive or negative growth trends in a plant surrounding area could provide insight into how the sites would possibly perform differently in the future. And then just, looking at these other 3 plants besides Armstrong and Crombie, so they all kind of performed middle of the road, between 250 and 350 people per square mile. So they're less viable than Armstrong, but they're still potential sites. And they also have negative growth, which is something else that's good to consider. But, being closer to a major city with a large centralized population, closer than Armstrong per se, that could also benefit them in a way from a more localized baseload power source. The SMRs could be, which could possibly increase their attractiveness and mitigate some issues of public pushback. So looking at site area, again, site scored pretty well under this because the benefit of SMRs is their relatively small footprint, and coal-fired power plants typically require a significant amount of land. The results are pretty expected. Also, this report heavily favors larger sites for various reasons, as I kind of mentioned earlier. But it's possible that certain developers might actually want to target smaller sites to suit their specific needs. So it's recommended that developers would then tailor this criterion to meet their goals. And I'll kind of mention that again in future recommendations. Looking at site slope, here all the sites actually scored perfectly. So, unsurprisingly, again, that each site scored so well because these sites had functioned as power generating stations with preferred site characteristics. So it's likely that the slope, was already a selection criteria that they'd used before development, or the site was then leveled before the coal plant was put in. So decommissioned coal plants having very low ground slopes is likely to be a trend throughout the US, not just in Pennsylvania, suggesting that siting an SMR at a retired power plant could eliminate certain costs from site preparation. USGS data was used here to determine the safe shutdown earthquake, so that SS8 peak ground acceleration for each plant, and then the FEMA earthquake hazard risk census tract levels were noted, or the risk at the census tract level was noted as well to confirm the USGS findings. Same thing here with site slope. All of them received a perfect score. So kind of looking into this a little bit further, it's clear that most of Pennsylvania is low risk. In fact, most of the map east of Colorado has low seismic activity. So locations that are further away from tectonic plates are likely going to be better for siting SMRs, compared to siting it in places like the West Coast, which earthquake hazards, are pretty common there, pretty high level of risk. And so earthquake hazards should be prioritized in regions like that, and it could play a greater role in determining viable sites for nuclear development than it did in Pennsylvania. So here, as I mentioned, FEMA was used to determine the risk level and also the risk index score. Census tract level data was used as it allows for more granular data, making the analysis a little bit more accurate than if regional data was used. So overall, the sites showed a generally high risk for landslides. Despite some sites' census tracts having a higher risk of landslide, though, this criterion still does not exclude any sites, hence it's not a multiplier. One reason being that nuclear reactors have still been built in census tracts with moderate to high landslide risk. Peach Bottom Atomic Power Station and Susquehanna Steam Electric Station are both in Pennsylvania, and they're both in census tracts with relatively moderate and relatively high landslide risk. And also, given that a coal plant was built there at one time, it indicates that the landslide risk is an important consideration, but it's not a limiting factor on development. So again, same source of data here, just looking at riverine flooding. Obviously, no coastal flooding. None of the plants are on the coast. So most sites, except for FR Phillips, scored pretty well. Now, it's possible that the risk of riverine flooding would be lower for the actual census tract, but higher at the exact site because all of the sites are located along rivers. But even if the risk of flooding at each site is higher, this parameter alone isn't sufficient enough to exclude it. Because again, nuclear plants operate in Pennsylvania in census tracts with high river flooding risks. And so environmental hazards are a large part, environmental hazards in general, so flooding, landslide, earthquake, they're a large part of the desktop review sort of a site before moving forward with development. However, most hazards don't prevent development of a site. In fact, most of them can be dealt with, site preparation. It's just that it's expensive. And then there can also be increased insurance costs and additional equipment that would be needed to safely operate SMRs in areas with environmental risks. But this could also be balanced by a higher regional need for baseload power, which would result in, higher available power pricing. So when we look at stream flow, every site, like I said, is located along a river. All of the stream flows, their average over the past 90 years well exceeds 130,000 gallons per minute. So, the results match with the assumptions that we had. It should be noted that the average stream flow values may overestimate the actual amount of available stream flow at each site, just because the water demands of a power generating site must be balanced with drinking needs, industrial and agricultural water needs as well. But because the average stream flows are significantly higher than the ideal value, and with the potential for SMRs, their water requirement to be drastically reduced, there's still a high level of confidence in the results that all the sites rightfully earned a very suitable score under this criteria. So an EIA map containing the location of all energy infrastructure resources, including transmission infrastructure, was used for this, and then additional information from the PDCED. So each site essentially already has transmission lines on site, which is great, or less than a mile away. A lot of them have substations, earning all fours, which again was expected. Decommissioned coal-powered plants, my goodness, were delivering power to the grid before they were shut down. So it stands to reason that they would have established transmission infrastructure on site already, which makes development much less expensive. It reduced costs associated with interconnecting to the grid, which highlights the opportunity for decommissioned coal plants to be more economically and technically desirable for SMRs. And so, most decommissioned plants in the US would follow a similar trend as this. So a site's distance to existing transmission infrastructure may have little impact on determining which coal plants, specifically are more suitable. Multiple data sources were used in gathering this information, and so the hazardous operations looked at specifically are airports within 10 miles, and then military, missile generating, toxic gas generating facilities that are within 5 miles. So most of the airports are small regional airports, the one exception being Pittsburgh International Airport being close to FR Phillips. None of the sites were found to have any kind of military facility or missile generating facility within 5 miles. El Ramo was near a coke processing plant, so that's the toxic gas generating facility. So, the number and kind of facilities can indicate a level of opposition to SMRs here, so it's important to identify them during site evaluations to help guide development, but it's not ultimately going to exclude a site necessarily from SMR development. So the Pennsylvania Department of Environmental Protection created a Penn EnviroScreen model that basically combines pollution burden and pollution characteristics and population characteristics, data to identify environmental justice areas in accordance with environmental justice policy. So a binary scoring was originally going to be used to denote either yes, this is in a census tract considered an environmental justice area, which would be sites that score above an 80th percentile, according to the Pennsylvania DEP. And sites underneath or below 80th percentile are not environmental justice areas. But I just felt that this would inaccurately represent the suitability of a site in the 79th percentile, because it's not technically an environmental justice area, but it is still very much an area of concern that has been unfairly and negatively impacted. So it's unsurprising that most sites are in areas where environmental justice is a concern, as the retired coal plants at those sites may have caused or at least contributed to high levels of pollution in those communities. Major polluting projects, are typically located where land is cheap, facilities are cheap, and there's little organized opposition, which unfortunately ends up impacting minority and low-income communities. So having scored low in general under environmental justice, it's imperative to ensure that putting an SMR here, in those locations would not negatively impact the surrounding census tracts any further, which could require extensive mitigation measures for environmental injustices, primarily concerned with proper waste management for SMRs, radioactive materials, and just really limiting any disproportional impacts on disempowered communities. And so these sites should be flagged for reevaluation in future years also to identify positive or negative trends, if they're improving or regressing in terms of environmental justice issues. So only 2 sites were actually located in non-attainment zones for ozone or particulate matter. Pennsylvania has a deep-rooted history in fossil fuel utilization for electricity generation. which can contribute to the creation of ozone and emissions of particulate matter. And so that has led to the designation of non-attainment zones in the state, because ozone and particulate matter can negatively impact human health. And so again, citing SMRs here could be slightly preferred. Just an interesting thing to note that FR Phillips is within an EPA non-attainment zone, but is also in an environmental justice zone. So in this case, it's likely that being in a non-attainment zone would have less impact on mitigating public opposition for SMRs, considering it's in an environmental justice zone, which is reflected by environmental justice having that 0 to 4 scale, so it can impact the viability more, as it should. So looking here, we can just kind of visually see trends of how sites scored. So again, sites generally scored well within site slope, an earthquake hazard, nearby transmission, stream flow, things like that. And then in the bottom corner, there's the equation that's used to calculate the actual final scores that you can see in the last row of the table. So despite performing well under most of the criteria, Crombie was found to be not viable for SMR deployment because it failed to meet the population density requirements. And then Armstrong received the highest normalized score of 0.76, making the decommissioned coal plant an ideal location for SMR development. And this was primarily due to it having very low population density, which greatly increased the viability because it's a multiplier. And then the remaining 3 fall into the less viable group. I won't go too much more into this because I just went through all the individual scores. So here we can just see visualize on a map, the final site status, categories that each plant falls in, using the legend down below. And then this can be used to help prioritize SMR development toward the sites that are most economically and technically attractive ones. So going to conclusion and future recommendations. Following conclusions were made relating to nuclear power deployment from the results of this project. Decommissioned coal plants are ideal locations for SMRs, not just in Pennsylvania, but in general. This is because environmental hazard risks at retired coal plants, for the most part, have already been managed, allowing for power generation operations at the site previously. Also, many site characteristics are similar between coal and nuclear, such as site slope, area, and available stream flow. And most of the retired coal plants still have existing transmission infrastructure on site, further decreasing development limitations for SMRs. While coal and nuclear development follow similar guidelines, there we go, pertaining to site characteristics, siting nuclear reactors must follow stricter protocols pertaining to public safety than when dealing with siting coal plants. So population density was identified as a key driver for SMR development that can severely impact the site's ability to support SMRs. Therefore, large sites in rural, low population areas have a higher potential to be suitable SMR locations because these sites present fewer barriers and lower costs associated with nuclear development. On a broader note, these results also suggest that Pennsylvania is a good place for power generation development in general because of relatively low environmental hazards and very established grid and larger areas with low population density throughout the state. Future work can include an in-depth economic analysis, or it should include, that's planned for whoever takes over this project next. So yeah, an economic analysis to determine the financial viability of deploying SMRs at one or more of the coal plants evaluated here. It's recommended to include, honestly, all 5 plants, just to allow for a comparison between the results in this work presented today and the actual estimated costs. So, was Armstrong that was found to be the most viable? When you do a economic analysis, does that actually turn out to be the cheapest one or not? The economic analysis should evaluate the capital and operational costs of the coal plant retrofitted for SMRs. All relevant subsidies and economic incentives should be identified to then model the financing options. An important aspect to include in future work that was not discussed in detail in this report would also be important or would be identifying the quantity and type of nearby power generation to the site. It would also be important to note if nearby generating sources are baseload plants or peaker plants, because this can help gauge electricity supply and demand needs at a given site. Additionally, the site assessment criteria could be adjusted for future coal plant evaluations to more accurately reflect the needs of the developer. So again, this approach was meant to be repeatable, but it can also be a little bit customizable. So for example, a criterion scoring used in this report were made to favor larger sites, as I had mentioned. But if a developer wants to target smaller ones, then they can totally adjust the scoring criteria to reflect that. And then, you know, in situations of being located in different regions, such as having to consider riverine versus coastal flooding in the criteria. And also, you know, the environmental justice criteria as well could be given more weight. It could be turned into a multiplier given the, you know, ethical considerations of it. But again, that'll sort of be up to the developer as well. And then as new advanced nuclear reactors become commercially available, updated siting guidelines maybe, you know, published that are specific to small reactors. And in this case, SMR site suitability criteria should then be adjusted accordingly so that it reflects the most recent regulations available. So thank you for staying with me through that very long presentation on here. I would take questions now, but this is a remote audience. So I want to say thank you very much.